we will learn about the differences between 2D elements in S-frame. There are different 2D elements available in S-frame that can improve the efficiency and accuracy of the modeling process. S-frame provides support for diaphragms, panels, and both triangular and quadrilateral finite elements. Let's take a look at the panel elements. If we go to the panel element tool, you will see all these options you have to define your panels. And I have defined some columns. So we have 6 columns. The first panel type that I want to introduce to you is the general diaphragm. A general diaphragm doesn't have center of mass, material, or thickness, and is used to constrain all joints that are positioned on the same plane. In this case, the same plane that is parallel to the XY plane. In this example, I will show you now how to create a general diaphragm at nodes 2, 4, 6, and 8. I'm going to start creating my panel. So we select general diaphragm and we click on joints 2, 4, 6, 8, and we close at 2 once again. In this example, this general diaphragm is between nodes 2, 4, 6, and 8. And this means that all joints within the XY plane belong to that constraint set. Therefore, joints 10 and 12 are also part of the general diaphragm. Now, let's take a look at the rigid diaphragm. Let's use the same panel I have created, but in this occasion we're going to click rigid diaphragm and we are just click and drag over the center, the panel which is called the panel handle. Once selected, you can see the color changed to light blue, and a rigid diaphragm constrains all joints within and along the borders of the object. The center of mass is supplied, which means that thickness and material density can be defined. Please bear in mind that these properties do not alter the stiffness, but do add mass to the diaphragm in the X, Y directions and rotational mass about the Z axis only. Rigid diaphragms can also be defined as triangular, quadrilateral, or polygons. Diaphragms using the tools in the geometry window of S-frame. For example, let's add another rigid diaphragm. I'm going to add it here. And I'm going to close in 4. Now I have 2 rigid diaphragms. If they are in the same plane, a single set of joints with a common center of mass is created. So these diaphragms, they share a center of mass, and if we click in this tool, the verify diaphragm nodes, we can see that they all go to the center of mass, which is located here. Let's click on that tool again. Now, if one of the diaphragms is made independent, like this one, let's select independent diaphragm. S-frame will maintain 2 independent sets of constraint joints with 2 independent centers of mass. So if we click the verify diaphragm nodes, we will see that the center of mass is located at the center of each diaphragm. If a general and independent diaphragms are used on the same plane, all joints in the plane not belonging to that independent diaphragm will be slaved to the general diaphragm. So if we select general and we click here, we change the property to general diaphragm and we click once again to verify, we'll see that it goes to the center of mass right here, and independent is just as we used to be. So this diaphragm is taking into account all nodes, and this one is only taking into account these 4 nodes. The Same way, we have all these 2D elements. We call them panel 2D elements, which can be polygon shaped elements that can be used to define area loads, diaphragm elements like the ones we saw. Now let's proceed finite element types, which unlike diaphragms and panels, finite elements have stiffness and mass dependent upon their material and thickness. These elements are used to more realistically model physical components of structures. We'll see these three types of rectangular elements, the same as you can see in the triangular elements. We have the membrane type element, which has in-plane stiffness only, in both tension and compression. A membrane element can be thought of as the 2D equivalent of a truss element. Membrane structures are used to model very thin floor systems with minimal vertical loadings or fabric structures. We have the plate element, which has out-of-plane stiffness only and is often used to model floor systems not designed to transfer in-plane loads. And finally, we have the shell element, which is the most frequently used finite element and support both in-plane and out-of-plane loading. A shell element can be thought as of the 2D equivalent of a beam element. Shell elements are well suited to model walls, floors, foundations, and roofs. More information about these 2D types of elements, tips and tricks, can be found in this document. So please feel free to get in touch if you would like to have access. Here you will find all the information related to this presentation, from diaphragms, panel 2D elements with some examples, area load panels, and the finite element types, membrane, plate, and shell. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.